Hey everyone, welcome back to our 1.9 absolute value graphs notes. So in this section, we're going to talk about how to graph absolute value functions using transformations. And they all start out with the same graph called the parent function. And we're going to be able to graph them, and then we're actually going to use the graphs to solve some equations and inequalities, which is actually my favorite part because that means that you don't have to solve the actual equation. Okay, so first things first, I'm going to show you the parent function. This is going to be the only time I end up actually using the table. I'll use the table, I guess, on one other problem, but then the tables are there for you because if you ever wanted to graph something you weren't familiar with, all you would do is take the x value that it's giving you in the table and plug it in. So for like this first one, the absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. And now I have 5 points. The first one, -2, 2, is left 2 up 2. And I'm going to switch colors for you. There we go. And then -1, 1 is left 1 up 1. 0, 0 is right in the middle. 1, 1 is right 1 up 1. And 2, 2 is right 2 up 2. So you can kind of tell it's starting to make this V shape, and that is the absolute value graph. It makes a V, easy to remember because absolute value starts with a V. Then it's going to ask you about the domain and range. In case you don't remember from Algebra 1, domain is kind of like interval notation. We're going to write left side, comma, right side, as in how far to the left does it go, and then how far to the right does it go. And we're mainly looking at x values here. Okay, so on my graph to the left, it just keeps going because of that arrow. And on the right, it just keeps going because of that arrow. So what we do is we call that infinities. On the left side, it's always negative infinity. And on the right side, positive infinity, or simply infinity. Just like in inequalities, we're going to use parentheses around these because you can't equal infinity. For the range, you're going to do the same concept but for the y values. And y values go up and down. So we're going to go from the bottom to the top. And again, we're looking at our y values. So the bottom of this graph is right here at 0, comma, the top is infinity. It keeps going up. Okay, and then the infinity gets a parentheses. The 0 gets a bracket because there actually is a point right here where y is 0. All right, now let's talk about the transformations. So there are various transformations that show up in the equation. For instance, if you're going to shift the graph to the left, that's going to show up as a plus on the inside of the absolute values. If it's going to the right, it's going to be a minus inside the absolute values. And be very careful with those two. The right side is actually a minus, the left side is actually a plus. Those are kind of backwards. And then the vertical transformations happen on the outside. Plus on the outside is up, the way you would think, and a minus on the outside goes down. Then we have our vertical stretch and shrink. So for the vertical stretch, this is going to basically be the slope, okay? And it's going to be a number that goes in front right here. So it's going to be like a coefficient almost. Okay, and that number right there, just like a normal coefficient in like y equals mx plus b, is going to be the slope of the line. Okay? And actually, I'm going to go ahead and say that it's the slope on the right side because and I'm going to backtrack in just a second to show you. The slope on the left side is the same but negative. And then the only thing that happens if there is a vertical reflection is there's going to be a negative out front, like that. And this means that the graph is going to be upside down. Okay. But really, this plays into the same thing as this, that the slope on the right side will just be negative instead of positive. And I know that doesn't make a whole lot of sense just yet, but it will once we've done a couple examples. Okay, coming back to our graph over here, you'll notice that the slope on this one is 1. It goes up 1, right 1, up 1, right 1. And on the left side, it goes up 1, left 1, up 1, left 1. Okay, so what's going to happen if we have a negative is instead of going up 1, right 1, it's for instance going to go down 1, right 1 like this. And the left side just does the opposite of what the right side does, or it goes up or down the same amount, but instead of going to the right, you go to the left. Okay, that's still your original absolute value function there. All right, let's talk about some transformations. So this one has a -2 inside the absolute values, and a minus inside means that it's going to the right. And it's going to the right 2, because the 2 is being subtracted. That just means that instead of starting here at 0, 0, you're going to go to the right 2 and put a point there. And then you fill in the rest of the graph with the v. Up 1, right 1 a couple times, and up 1, left 1 a couple times from the middle. And notice how I came back to the middle and then went up 1, left 1. So basically, it's like picking all the pieces up and moving them to the right 2. Same V shape, just to the right 2. Okay. Then we're going to come down here and look at the domain and range. Remember that the domain starts off with how far to the left. Going to the left of my graph, it just keeps going to negative infinity. Going to the right, it keeps going to positive infinity. And then we're going to use parentheses because we don't use brackets around infinities, since you can't equal infinity. For the range, the bottom of this graph is still at y equals 0. That hasn't changed. And the top of the graph is still going up to infinity. That hasn't changed. The only thing we changed is the x values. And they were going from infinity to infinity. So adding or subtracting 2 from that doesn't really change anything. Okay, I'm going to skip this one and do it in class. So make sure you skip this problem on your notes. Okay, I'm going to skip to this one, where it has the absolute value of x minus 3. Okay, and what we've got going on here is a minus on the outside, which means we are going down 3. So instead of starting at 0, 0, I'm going to go down 1, 2, 3, and start there. Nothing else has changed, so it's going up 1, right 1. Do that a couple times. And then from the middle again, up 1, left 1. And this middle point right here is called the vertex. That is the first point you want to move, the point in the middle, and then everything else kind of follows after that. It's the center point. Okay, my domain is still negative infinity to infinity. But my range, the bottom of it, is now at negative 3. So it's going from negative 3 to infinity. Because we moved the graph down, the range moves down 3, from 0 to negative 3. Okay, I'm going to skip this one and move to the back side. So on that front table, I had said that this number right here acts like the slope. So basically, it's going to have a slope of 3 on each side. Okay, the left side is just going to have the negative 1. Nothing else is changing, so it's still going to start right here. And we're going to do a slope of 3, which means up 3, right 1, up 3, right 1, or up 3, left 1, up 3, left 1. So see how stretched out this graph is? That's because I has a slope of 3 instead of 1. But my domain is still negative infinity to infinity. It's still going to the left and to the right forever. And my range is still, bottom part is at 0, 0 to infinity. Next up, this one. So that negative 2 out front is going to be the slope on the right side. So now our slope is negative 2. That's the only thing changing about this graph. I'm still going to start in the middle at 0, 0. And then instead of going up 2, right 1, I'm going to go down 2, right 1. Down 2, right 1. Down 2, right 1. And then I'm going to go down 2, left 1. Down 2, left 1. Down 2, left 1. So each half of the absolute value graph kind of is just a mirror of the other side. Okay, my domain still goes left and right forever. If you haven't caught on by now, that's not really going to change about any of these graphs. The only part that changes is the range. And this time, the bottom of my graph keeps coming down here forever. So the bottom is negative infinity, comma, the top is 0. And because there's actually a point up there where y equals, 0, we get to use a bracket. All right. I'm going to skip the 1/2 x and go straight to this one. The negative 4 is a minus on the inside, so that's going to the right, 4. And the minus 2 on the outside, minus is down, so down 2. Which means I'm going to start at 0, 0 and go right 4, down 2, and that's where my graph starts. And I only have enough space to go up 1, right 1 once, and then I'll go up 1, left 1 a couple of times. And there you go. The domain, still negative infinity to infinity. The range goes all the way down to negative 2. And then it goes up to infinity because there's arrows going up. Okay. Now let's try solving an equation. So when we're solving the equation, we're basically going to act like y equals the right side or left side, and then y equals the right side. So you're going to graph both of these lines. And actually, I'm going to go ahead and do this. I'm going to do the y equals 2 in the greenish color. So y equals 2, following Hoybucks. Y equals lines are horizontal. So I'm going to go to y equals 2 horizontally. There we go. And I'm looking for where the graph of what's on the right side or left side crosses this. So we're going to need to graph the absolute value function and move it. There's a minus on the inside, so that's right 2. And then the minus on the outside goes down 3. So right 2 from 0, 0, 1, 2, and then down 3, 1, 2, 3. And then nothing else is different about our graph or our absolute value function. So it's going to keep going up 1, right 1 until it hits that line. And I know it's slightly on the edge of the graph. That's going to be at 7. So that's one answer. And then the other answer is if I go up 1, left 1. It's going to cross again at -3. Okay, and I'm going to save the inequalities for a class.